Hello everyone and welcome to this video series of graphing quadratic functions. In this we are going to see like using transformations how we can graph quadratic functions. Okay, let us start our discussion with parent function. What is a parent function? It is the simplest function which has all the characteristics of a family, like the simplest mole function you can say. Okay, now what we will do the transformation in this function and we will get our desired function. Let me elaborate my point with some examples about parent functions. Like if it's a constant function, what is that? F of x equals to c, the graph is always a straight line. These are some predefined functions or parent functions. If it is linear, you will see the graph of a linear is always a straight line. Our target is what? We are going to focus quadratic equations in this video. What is the quadratic function? The simplest function f of x is equals to x square. Okay, let's have some debate on this. F of x is equals to x square. Okay, remember the vertex form. Vertex form of a quadratic function is what? It is a into x minus h square plus k. So if I rewrite it, it's what? A is 1, x minus 0 square plus 0. It means the value of h is 0 and the value of k is also 0. So vertex of this function is what? 0, 0. And we know that the vertex is the point where the graph usually turns, the parabola turns. This is the vertex of this graph. Now what we are going to do, we are going to transform this. We will see like what will happen if we transform this function. Like if the vertex is not 0, 0, how we can use this graph, the simple graph, to get the new graph. Let's see this. Translations. For this, let us use the parent graph. What is the parent graph? It says f of x is equals to x square. Okay, let's have some vertex here. We say f of x, sorry, h here, f of x minus h. What impact it will have? It will be x minus h square. Okay, now what will happen? The graph which was before shifting on 0, 0 here, because the vertex of this graph was 0, 0. Now the vertex is not 0, 0 because there is some h involved. This h will shift this graph either to the right side or it will shift it to the left side. And how we can determine it will go to the right side or it will go to the left side? If this value of h, if it is less than 0, we say the graph moves towards the left side. And if this h value is greater than 0, we say the graph will move to the right side. Okay, because it is h is responsible for x-axis, so it will only move the graph left or right. If the same graph we have the parent graph f of x is equals to x square and there is k involved, f of x plus k, it will be what? X square plus k. Okay, now this k is not responsible for x-axis. This is the shift in the graph on the y-axis. This is the parabola, simple one. Okay, let's say the vertex is 0, 0. Now this value, this y-axis value, will be changed because of this k. This k is responsible for shifting the graph up or down. If the k value is greater than 0, the graph will shift up, and if the k value is less than 0, the graph will shift down. Now we have the four possibilities. We have seen the h also, we have seen the k also. We saw how it can move to the right side, how it can move to the left side. Now let us practice this. Let us solve a question and see if we can practice this concept. We have a function g of x equals to x plus 3 square plus 1, and what we want to transform this. We want to transform the parent function and we want to draw this graph. So let us compare it with the general function, the parent function. It is what? G of x is equals to, if you write the general form, it is what, the vertex form, a into h minus x square plus k. So if you rewrite it, you will get what? A is 1, so x minus into minus 3 square plus 1. How I got it minus 3? Because it was plus, I need a minus here, so I break it. I wrote minus minus. It is the same function. Minus minus will again become plus. So here you see what's the value of h? h value is -3, and k value is what? K value is 1. So this is telling me what? It is telling me that my graph will shift 3 units, and where it should shift, left or right? It should shift left because my h is less than 0. So 3 units left and 1 unit up. So my vertex will be shifted. How my vertex is shifted? It before it is 0 0, because here when you have this h and k 0, it was 0 0. Now I have my vertex as -3 and 1, so I have to shift my graph accordingly. This is 0 0. Now here -1, -2, -3, this is -3 and 1 unit up, so this is my new vertex. This graph which we have here, now we will shift it here, same way we shift it here. Okay, so here it is, I not draw it properly, my hand like that, I tried roughly, it will be something like this, and this vertex will be labeled as -3 and 1. This is how we shift the graph. Okay, let us do another example for practice. We have x minus 2 square minus 1. What we will do, we will compare it and we will get the value of h and k. Like the vertex form is what? A into x minus h square plus k. So comparing this, if you see this is already a minus, so what is the value of h? H value is what? 2. And what's the value of k? K value is what? -1, because here should be a plus, right? It is like this, x minus 2 square plus -1. So h is 2. We don't count this negative because in the standard form it is also negative. So h is 2 and k is -1. It means what? My graph will shift 2 units, right? Because k is positive, and 1 unit up down because it is -1. So let's do this. It is 0. So 2 units to the right we reach here, and 1 unit down we reach here. This is our new vertex. This is our new vertex. Now we draw same graph, this same plotting which we have here, we shift it here. Okay, and we will get something like this. It's a rough sketch, you can do it properly. Like this you will get, and you will label the vertex as 2 and -1. This is how you can shift vertexes, like from the parent function. If you have the value of h and you have the value of k, how you can move the graph to the right, to the left, or up, or to the down. Okay, next time we are going to see how we can do reflection, stretches, or compression. Like this is just shifting of graph, like here we just moved it up, down, right, left. Next time we are going to see if we want to compress it, if we want to stretch it, how we can do that. Okay guys, thank you so much for your time. If you understand something, please also subscribe and like this video. Thank you so much.